Okay, let me revise the things what we discussed in the previous session. Just concentrate. In the previous session, we discussed the need of a transformer, the definition of a transformer, and its working principle. Let's try to revise the things. If you try to read the definition, the transformer is a static passive device which transfer the electrical energy from one point or one circuit to another point or another circuit without change in its frequency. As you know that the transformer is an example of statically induced EMF. Statically induced EMF means what? The statically induced EMF, it means that where conductor is stationary. That's why the transformer is called as a static device, because transformer does not consist of any rotating, movable or vibrating part is there. All part of a transformer is a stationary. That's why transformer is called as a static device. Why it is called as a passive device? Because it just receive the energy from one circuit or one point, and it will deliver the energy to that another circuit or that another point. It will not amplify the signal, it will not generate the signal. That's why it is called as a passive device is there. And what is the basic purpose of the transformer? The transformer basic purpose is to transfer the electrical energy from one point to another point, or we can say that in another word, one circuit to another circuit is there. But very important thing related to the transformer is without change in a frequency. It means that output frequency of transformer is always equal to the input frequency. Most of the times this question or this sentence, it may ask for MCQ type of a question. That MCQ, it may be like that the output frequency of a transformer is, then your answer should be same as the input frequency. Okay, and then we discussed that the basic construction. In the basic construction of a transformer, the transformer has its three essential parts. One is the core of the transformer, which is made with the silicon steel. Why this material is used? Because it offers the low reluctance path is there. Then second is the primary winding, and third one is the secondary winding, and both the windings are made up with the copper material. So this is the basic diagram, basic construction view of the transformer here. Here, the main part of the transformer is the core of the transformer, which is made up with the silicon steel, and the two winding. Then how you can identify which one is a primary and which one is a secondary is based on the winding which accept the energy, or which will, or the winding which is connected to the supply. That winding we call it the primary winding. So this is, we call it a primary winding because it will receive the energy from that one circuit. And the winding which will deliver the energy, that winding we call it a secondary winding is that. So these are the three essential part of the transformer here. And then if you see that the basic working principle, then I have already told you this is the core of the transformer made up with a silicon steel. So here, if you see this rectangular core of the transformer, these are the two vertical sides of the core of the transformer. And on these two vertical sides, two windings are wound. Suppose I consider that this is the primary winding. Why I say that primary winding? Because it will receive the energy, so that it is considered to be connected to the supply. This is connected to the supply voltage. Suppose we consider that the supply voltage is of V1 volt, so that this winding will receive the energy, so that it is called as a primary winding. And the number of turns of the primary winding, let's we assume that it's a N1. And on that opposite side of that core, the another one winding is wound, which will deliver the energy, that is called as a secondary winding. Why we call it a secondary winding? Because this winding will deliver the energy. कारण आपण बेसिक डेफिनेशन मध्ये काय बघितलंय, की द ट्रान्सफॉर्मर विल ट्रान्सफर द एनर्जी. मग तो एका सर्किट मधून एनर्जी घेणार आणि दुसऱ्या सर्किटला एनर्जी देणार. But how it receive the energy and how it deliver the energy, which is nothing but the basic working principle here. So this is the secondary winding. As we say that it will deliver the energy means the terminal of the secondary winding is connected to the load. The load, it may be anything. तुम्ही filament lamp घेऊ शकता, fan घेऊ शकता, tube घेऊ शकता. It means that the load, it may be resistive, inductive or capacitive or combination. Get it my point? And here we say that the voltage generated across this load, we call it so V2, and the terminal number of turns of the secondary winding, we call it so N2. Now you just assume that here we are connecting the AC voltage to the primary winding. Now what is meant by that AC voltage, or what is meant by that AC current? If you know that the DC current means what? The current which has its a constant magnitude in a one direction, that current we call it a DC current. The current which has its a constant magnitude with respect to time in a one direction, we call it a DC current. But alternating current means what? The current which will change its magnitude as well as direction with respect to time. This current, we call it a alternating current is there. And the basic requirement is that when the alternating current, it flows through the primary winding, let's we assume that it's a I1, we call it a primary current. When the alternating current, it flows according to the Faradays law, this alternating current or change in current in the primary winding create the alternating magnetic flux in this way. This is the alternating magnetic flux, and this alternating magnetic flux, it can be represented by phi is equal to phi m sine omega t. Just like that, how I can write that alternating current? I is equal to I m sine omega t. So this alternating current will create the alternating magnetic flux in the core, and this alternating magnetic flux can be represented with that equation phi is equal to phi m sine omega t. Is it that clear? Yes or no? Do you remember that this equation? Hey, equation तुम्ही बघितलं असेल याच्यापूर्वी? Yes or no?
Yes, sir.
Okay. Now, when this alternating magnetic flux, it flows through the core. This is the expected path of a core. This is the expected path of a magnetic flux. I say that expected path through the core is there. And as we know that on the two sides of the core, the two windings are there. When this alternating magnetic flux flows in the core, definitely it link with the both the winding. And when this alternating flux link with the both the winding, according to Faraday's law, EMF is induced. Suppose I consider that EMF induced in the primary winding is E1 and the EMF induced in the secondary winding is a E2. But here E1 EMF induced in the primary winding is known as self-induced EMF. Why we call it a self-induced EMF? Karan, why that alternating flux it will produce here? Due to the change in its own current. कारण त्या प्रायमरी वाइंडिंग मधला करंट चेंज होतोय आणि त्या करंट चेंज मुळे अल्टरनेटिंग मॅग्नेटिक फ्लक्स तयार होते, त्यामुळे त्याच वाइंडिंग मध्ये तयार होणाऱ्या ईएमएफ ला आपण काय म्हणणार आहोत? सेल्फ इंड्यूस्ड ईएमएफ. and the EMF induced in the secondary coil, that we call it a mutual induced EMF. It means that according to the Faraday's law, the EMF is induced, and if secondary coil, if it is closed with the load, then definitely secondary induced EMF will circulate a current in the secondary winding. We say that it's a secondary current. And when the secondary current, when it flows through the load, according to Ohm's law, the voltage is developed. It means that as you have applied the alternating voltage at the primary side, it can be transferred from primary winding to the secondary winding through the load in this transformer by using this working principle here. It means that the transformer will transfer the electrical energy from one point to another point. Is that this is the working principle here, and that's why we say that the basic thing related to this working principle of a transformer is the mutual induction. Due to this mutual induction, that EMF is induced in the secondary coil, and because of that the voltage is developed across the load connected to the secondary side is there. Get it my point? Now try to read that the definition once again, but before that there are few terms are there. See that what are these terms are here. This V1, what is meant by this V1? V1 is the primary terminal voltage. Primary terminal. Why I say that it's a terminal? Because it is connected in between the two terminals of the primary winding. Similarly, V2 is the secondary terminal voltage, because in between the two secondary terminals the load is connected and across which this voltage is developed. That's why we call it a secondary terminal voltage. Then N1 is the primary number of turns, N2 is the secondary number of turns, E1 is the primary induced EMF. आता मला वाटतं लास्ट टाइम कोणीतरी प्रश्न विचारला होता की the voltage and that induced EMF. But this EMF is, its a unit is a voltage. This is also the voltage is there, but as per the Faraday's law, I use that word, it's a induced EMF. Get it my point? Here in this case, this E1 is approximately equal to the V1 here, because this is the supply voltage is there. E2 is the secondary induced EMF. Phi is that in this case, this is the alternating magnetic flux. I1 is the primary current and I2 is the secondary winding current is there. These are the few terms that we have to use while explaining the construction of the or the basic principle of the transformer is there. Now try to read it very carefully, line by line. The transformer is a static device by means of which an electric power is transformed from one circuit to another circuit without changing its frequency. This is the definition. This is the basic view of a transformer, as I already explained that. Now read it. A transformer operates on the principle of a mutual induction between the two inductively coupled coil. Now what is the meaning of this inductively coupled coil? As you know that the transformer consists of two coils. One is the primary winding, other is the secondary winding, and the copper material is used. And when it is wound in a number of turns, actually this is called as an inductor. That's why the two primary and the secondary windings, these two windings are known as an inductively coupled coil. So that, once again try to read it. A transformer operates on the principle of mutual induction between the two inductively coupled coils. The winding in which electrical energy is fed. Primary कशाला म्हणायचं आणि secondary कशाला म्हणायचं हे इथे दिलेलं आहे. The winding in which that electric energy is fed, म्हणजे ज्या winding ला energy provide केली जाते, दिली जाते, is called as a primary winding, and the other from which the energy is drawn out, आणि ज्या winding मधून energy drawn out घेतली जाते, म्हणजे deliver होते, बाहेर काढून घेतली जाते, is called as secondary winding is that. This is a simple definition of a primary and the secondary winding is that. The primary winding has N1 number of turns, while the secondary winding has N2 number of turns. The basic transformer and its a symbol is shown in figure. आता transformerचा basic view तुम्ही बघितलाय. Now this is the symbol. If you see the symbol, As you know that transformer consists of three essential parts. One is the core. The core in the symbol, it can be represented with the two vertical line and the two inductively coupled coil. So out of that, one we call it a primary winding and another one we call it a secondary winding. So this is primary winding, this is secondary winding, and this one is nothing but the core of the transformer. हा याचा सिम्बॉल आहे बघा ट्रान्सफॉर्मरचा. सिम्बॉल लक्षात ठेवा. लक्षात येते? You cannot draw the symbol like this. Just check it. असा का ड्रॉ करू शकत नाही? का तर आपल्याला काय माहित आहे की the three essential components parts of the transformer, and this is not the inductor here, this is the resistor. That's why this symbol is totally wrong. Inductor should be like this. This is the inductor and this one is a resistor. Please note the difference between this resistor symbol and that inductor symbol is that. That's why you can see in the diagram also how the symbol is drawn. The symbol is drawn just like a coil. One coil acts as a primary, another one acts as a secondary, and in between the two vertical line represents the core of the transformer. This is a symbol. Okay, now try to read it. Next point. When alternating voltage V1 is applied to primary winding and alternating current I1 flows in it, producing alternating flux. And what is the formula for alternating flux? As I rightly mentioned, phi is equal to phi m sine omega t. Okay, out of that, this phi m is nothing but the maximum value of a flux. Get it, my point? So this alternating current I1 flows in it, produces alternating flux in the core. According to Faraday's laws of electromagnetic induction, an EMF is induced in the primary winding, which is given by. So what is the formula to induce the EMF according to that Faraday's law? So this induce the EMF, which is nothing but E1 is equal to minus N1 d-dt. This is the induce the EMF in the primary winding, because N1 is the number of turns of the primary winding and d-dt is nothing but the rate of change of flux. Now, where N1 is the number of turns in the primary winding, the induced EMF in the primary winding is nearly equal and opposite to that applied voltage V1. This is a very, very important line. Equal and opposite to the applied voltage V1. Get it, my friend? So this E1 is always approximately equal to the V1 is there. Get it, my friend? Assuming leakage flux to be negligible. आता ज्या वेळेस प्रायमरी वाइंडिंग मधून फ्लक्स तयार होणार आहे तो सेकंडरी वाइंडिंग शी लिंक होणार आहे. So in that case, during their travel, definitely the certain flux will leak, but that leakage is a negligible because, as I say, that it's a silicon steel material is used as a core of the transformer, and the silicon steel material offers a low resistance path. So that assuming the leakage flux is to be negligible, almost whole flux produced in the primary winding link with the secondary winding is there. Hence, EMF E2 is induced in the secondary winding, and this E2, it can be also written by E2 is equal to minus N2 d-dt, because E2 is the EMF induced in the secondary winding and the N2 is nothing but the number of turns of the secondary winding is there. Read it. Where N2 is the number of turns in the secondary winding, if secondary winding is close to the load, the current I2 flows in the secondary winding is there. जर secondary winding ही close झाली तर त्यातून काय होणार आहे? Current flow होणार आहे. Thus, energy is transformed from primary winding to the secondary winding through magnetic field. आता थ्रू मॅग्नेटिक फील्ड का म्हणलेलं आहे? जर तुम्ही केअरफुली प्रिन्सिपल लक्षात ठेवलं तर प्रायमरी वाइंडिंग सप्लाय व्होल्टेजला कनेक्ट केलेलं आहे, त्याच्यामुळं इलेक्ट्रिक फ्लक्स तयार होतोय, अल्टरनेटिंग मॅग्नेटिक फ्लक्स तयार होतोय. तो अल्टरनेटिंग मॅग्नेटिक फ्लक्स सेकंडरी कॉइलला लिंक होतोय आणि सेकंडरी कॉइल मध्ये ईएमएफ इंड्यूस होऊन पुन्हा तो इंड्यूस्ड ईएमएफ सेकंडरी करंट फ्लो करणार आहे आणि मग तुम्हाला आउटपुट व्होल्टेज जनरेट होणार आहे. That's why it is called as the transformer will transfer the electric energy from one circuit to another circuit magnetically. Because if you observe that here, the two coils are not having that any physical contact. Primary coil and the secondary coil are not having that any physical contact. Still, due to the concept of the magnetic circuit, the transformer will transfer the energy from one point to another point. This is the basic principle behind the transformer is there. Is it that clear? Okay. And now the last point of this second unit, which is nothing but EMF equation of a transformer here. And I try to derive that EMF equation is there. Suppose here I consider that this is the core of the transformer. I say that this is the core. This is the core of the transformer. Which material is used? It's a silicon steel. Suppose I consider that this is the primary winding, which is connected to AC supply. Can we connect the DC supply to the transformer?
No.
Yes or no?
No.
Why no? Because alternating magnetic flux will not generate, and the alternating magnetic flux is the essential part to operate the transformer here. Get it my point? So now here the transformer never operate on a DC supply. Please remember this thing is always operated on the AC supply here. This is the secondary winding. Okay, where we connect the any type of load. It may be resistive, inductive, capacitive. आता इथं मी बॉक्स दाखवलाय, परंतु तो लोड काही पण असू शकेल, बल्ब असू शकेल, फॅन असू शकेल, ट्यूब असू शकेल, टीव्ही असू शकेल. That's why I say that it may be the resistive, inductive or capacitive. And through this coil, this is the expected path of a magnetic flux, alternating magnetic flux is there. Now see that what happened. This is the primary winding. This is the secondary winding. Primary winding number of turns is a N1. Secondary winding number of turns is a N2. Now when the primary voltage, I say that V1 is connected to the primary winding, then definitely alternating current it flows. And due to this alternating current, alternating magnetic flux is produced. So that's why I say that it's a phi. And this alternating magnetic flux can be represented with that equation phi is equal to phi m sin omega t. मला वाटतं ही इक्वेशन तुम्ही 11th और 12th स्टँडर्ड मध्ये अल्टरनेटिंग व्होल्टेज किंवा करंटच्या बाबतीमध्ये ऐकला असेल. परंतु हा अल्टरनेटिंग करंट तोच आपल्याला अल्टरनेटिंग मॅग्नेटिक फ्लक्स देणार आहे. मग ज्या अल्टरनेटिंग मॅग्नेटिक फ्लक्सची जर वेव्हफॉर्म ड्रॉ करायची असेल, सो दिस इज आय से दॅट अल्टरनेटिंग, किंवा तुम्ही त्याला सायनुसोडल सुद्धा म्हणू शकता. Why I say that sinusoidal? Because the waveform of the flux is same like a sine waveform. That's why we call it a sinusoidal waveform or sinusoidal quantity. So here, if you observe that this is the maximum value of a flux, we can represent with the phi m in the positive cycle, and this is the maximum value of a flux in the negative cycle. We say that it's a minus phi m. Minus sign indicates that only the direction is opposite, nothing greater than that. So this is the waveform of the, either you can say that alternating magnetic flux, or you can say that sinusoidal magnetic flux is there. This is the waveform. Okay. Now, according to Faraday's law, as you know that induced EMF E is equal to minus N d phi by dt. Out of that, what is this n? N is the number of turns. And what is this E? E is nothing but EMF induced in the total number of turns. Suppose I consider that n is equal to 1. Assume n is equal to 1. It means that induced EMF per turn. Induced EMF per turn. That's why we assume that n is equal to 1. E is equal to minus d phi by dt, because here n is equal to 1. Now that time this small e represent the induced EMF per turn. According to the equation number 1, we can write E is equal to minus d dt of this phi. I can replace with a phi m sine omega t. Is it right? But if you check it, this phi m sine omega t, out of that phi m is the maximum flux, which is constant. So I can write minus phi m d dt of sine omega t. Now, what is the derivation of sine omega t with respect to t? It's a cos
omega t
omega t into omega. And now I can write E is equal to minus phi m omega, or better way, I can try to write it down that minus sign here, like that. And you might be aware about that. If I want to replace this cos omega t in terms of sine, and here I say that the minus cos omega t, if I want to replace in terms of sine, then I can replace with E is equal to phi m omega sine omega t minus pi by 2, which is nothing but minus cos omega t is there. Now this small e, it represents the induced EMF per turn. But when this induced EMF will be maximum, when this sine theta, which is nothing but sine omega t minus pi by 2, when this sine angle becomes 1, कारण sine theta ची maximum value किती आहे? 1 आहे. When sine omega t minus pi by 2, when it will be becomes 1, that time this small e having its a maximum value, and that maximum value is represented with a capital E to the base m. The capital E is nothing but, or this capital E to the base m is nothing but the maximum value. But when the sine omega t minus pi by 2 sine angle, it becomes 1, that time small e having its a maximum value, and this maximum value em, आता जर मी याच्या साइन ओमेगा टी इज इक्वल टू 1 पुट केलं बघा, तर ई च्या ऐवजी मी em पुट करणार, then we have that value omega into phi m, and this omega is nothing but that angular velocity. What is meant by that omega? Omega is nothing but 2 pi f into phi m. Here I give that reference. Omega is nothing but 2 pi f. That omega is the angular velocity in a radian per second. Get it, my friend? And now this is the maximum value of induced EMF, which is nothing but 2 pi f into phi m. Okay. Might be in the 12th standards, you might be learned that if I want to calculate that RMS value of induced EMF per turn, what I want to calculate? RMS value of induced EMF per turn, where n is equal to 1. That is nothing but, can I write it down here? RMS value which is equal to 0.707 into maximum value. Have you know this formula? Formula माहिती आहे का बघा RMS value? RMS value means what? मला वाटतं तुम्ही शिकला असावा. It's a root mean square value and which is equal to maximum value upon root 2 किंवा 0.707 into maximum value. आणि जरी तुम्हाला हे लक्षात राहिलं नसेल तर आता तात्पुरतं हे लक्षात ठेवा. In the next topic we will try to derive the derivation for that RMS value is there. Okay. So now if I want to write that RMS value of the induced EMF per turn, it is represented with a capital E, which is nothing but 0.707 into maximum value is EM. And now when I try to put that value, E is equal to 0.707 into 2 pi f phi m. Is it right? And now if you try to do the calculation of 0.707 into 2 pi, you will get induced EMF, RMS value of induced EMF per turn, which is nothing but 4.44 f phi m. आता हे जे काही इक्वेशन आपल्याला मिळालेलं आहे, हे इक्वेशन काय सांगतंय? This E stands for RMS value of induced EMF per turn. म्हणजे एका टर्न मुळे तयार होणाऱ्या इंड्युस्ड EMF ची RMS व्हॅल्यू देत आहे. Now if I want to write total induced EMF, total induced EMF in primary winding, how I can write? आता जर एका टर्नला एवढा EMF तयार होत असेल तर N1 टर्नला किती EMF तयार होईल? How you can calculate it? Just you have to multiply it with N1. So I say that E1 is the total induced RMS value of total induced EMF in the primary winding, which is equal to 4.44 f phi m N1. लक्षात आलं का बघा? मी काय केलं, फक्त ही 4.44 f phi m ही जो आहे ही एका टर्न साठी RMS व्हॅल्यू इंड्युस्ड EMF ची असणार आहे. त्याला जर N1 न मल्टिप्लाइड केलं तर टोटल इंड्युस्ड EMF मिळालं. सिमिलरली I can write total RMS value of total induced EMF in the secondary coil E2, which is equal to 4.44 f phi m. आता इथे N1 च्या ऐवजी काय लिहावं लागेल मला?
N2.
It's a N2. This is the EMF equation of a transformer. Get it my point? And then another one point is that आता जर मला हे इक्वेशन मॅक्सिमम फ्लक्स डेन्सिटीच्या फॉर्म मध्ये लिहायचं असेल, मॅक्सिमम फ्लक्स डेन्सिटीच्या फॉर्म मध्ये लिहायचं असेल, आय हॅव दॅट फॉर्म्युला. फ्लक्स मॅक्सिमम फ्लक्स डेन्सिटी इज इक्वल टू मॅक्सिमम फ्लक्स अपॉन ए. मग मी फाय एम कशाने रिप्लेस करणार? BM into A ने रिप्लेस करणार. And when I try to replace, then here I got E1 is equal to 4.44 f. आता phi m मी कशाने रिप्लेस करणार? BM A N1. Similarly, I can write E2 is equal to 4.44 f. Phi m I replace it with the BM into A N2. This is the EMF equation of a transformer in the form of maximum flux density. Is it that clear? बघा, आपण फॅरेडेच्या लॉ पासून आपण चालू केलो. E is equal to minus and d∅dt. पहिल्यांदा आपण n is equal to 1 पुटअप करून फक्त एका टर्न साठी RMS व्हॅल्यू मिळवली आणि पुन्हा त्यानंतर टोटल RMS व्हॅल्यू मिळाली. पण त्यापूर्वी आपल्याला हे अल्टरनेटिंग इक्वेशन माहित असणं गरजेचं आहे, so that we will try to put it. And then so see that this one is the first steps. Let me write it that it's A. This one is the second steps B, and another one is this one is the third steps C. ह्या 3 स्टेप्स लक्षात आल्या की तुम्हाला डेरिव्हेशन आलं बाबा. हे तुम्हाला अल्टरनेटिंग मॅग्नेटिक फ्लक्स इक्वेशन कसं लिहिलं पाहिजे, त्याच्यानंतर फॅराडेचा लॉचं इक्वेशन कोणतं आहे आणि RMS व्हॅल्यूचं इक्वेशन कोणतं आहे, हे 3 इक्वेशन लक्षात राहा. दीज आर द 3 की of this derivation. Is it that clear? Yes or no?
Yes,
Yes, sir.
Okay, so may I declare here our the unit, second unit, magnetic circuit, and the single phase transformer is 100% completed. Okay, let me